Welcome back, everybody. Looks like the microphone is working. Hopefully it's got good quality this go around. So, I was doing some work without you guys again. I thought, for a first mini PCB ever, should probably put a trimmer not just on the bias, but also on the emitter side and the collector side. So, yeah. And then need to add test points. And then since the potentiometers don't really fit on the 33 millimeter, gonna bump up to the 50 millimeter size. That way the test points, the potentiometers, they all kind of fit. While I'm at it, bump up the size of the resistors. I already ripped up the traces, so okay. Let's put another we'll put the pot on the high side. That way the noise from the wire will go to the power rail instead of the output signal. Is that the way to do it? Clockwise. Clockwise, we want the gain to go, which would be an increase in resistance. So clockwise, we'll send it that way. So we want the wiper to go up. Hey. Yes. Save. Okay. All right. So, I mean, I guess I could, this might make a little more sense to some students. Just send it like this. That. Okay. Move this guy. Give me a junction for visual effect. I didn't pull that one out down there, so I'm going to keep this guy clicked in. The potentiometer reference designator is facing down. All the other ones are facing right side. That's just the way it's going to be. UP, renumber sheet. I don't have any test points on here yet, so that's what we need to add now. Let's add some test points. So we've got a component that I made called Testpoint. I've got more options. The one with no text actually has text. Let's see. So we'll put one there. Move this guy out to say there. Copy. Put that guy like there. On either side of the pot, yeah, just for yeah, it's an educational board, so we'll do it like that. Rotate it that way. There. Move group, pull down to like there. So probably, well, not that one, move. drag this down a little bit, just to say like there. That's probably good. Move that guy up a little bit so it matches the front. No. Okay. Copy. Keep going. Output. Sure. This guy. Sure. I want to put one there. Yes. Okay. Then we'll drag this guy out to the end. Keep it in there tight. Keep it over there. That's probably fine right there. Test point 6. We need a test point on power and ground. You might say, why do we need one on power and ground? Well, because it's useful. There. You know what I could do is I could drag this out a little bit, pull this guy back in here, grab me a test point. No. I'll pull that one back in. It's fine. Okay. So TP9 is up here on these. I should put a test point in there so you can get the other side of that. One more click. Boom. Okay. Okay. Should I pull this guy so it looks up? Probably better. Save. Okay. I think that's it. I think that's all the test points. What? Okay. That should be good. With trimmers. Trimmers, test points. There we go. Five resistors. Is it really 5? 1, 2, 3, 4, 5, 6. No, it's not 5 anymore. Just should say AC coupled. Probably the number of resistors, but we don't need to talk about that. We'll just say think that'll be cut off. There we go. That'll work. Through-hole device, trimmers, test pots. Yeah, that's fine. Okay. So when this potentiometer is all the way, so the wiper is basically connecting 2 and 3, then the full resistance of potentiometer is applied to the circuit. And when the wiper is all the way to 1 and 2, then only the wiper resistance is in the circuit, which could be pretty low and could vary part to part. So R8 is a fixed resistor. So when the wiper resistance varies part to part, board to board, R8 quite significantly, R8 will not. So if R8 is large enough where the wiper variation doesn't really matter, or the tolerance of the wiper is averaged with the tolerance of this guy and their respective values. So yeah, okay. So I'm imagining off the top of my head, for this guy, I would put a 10K, right? And then it gives you a decent bias adjustment range. And for this guy, since these are low valued, like 10s, maximum hundreds of ohms, this guy is probably good at like a 100 ohm. And then this guy up here, since this is normally in the range of several K, so I think several K, maybe for 5 volts, maybe it's lower. Okay, so on this guy, brown, brown, black, green, or no, it's the other way. It's a violet, violet, green. So what's violet? A 4, and green is 7, so 4.7K. Is that what I put on there? Anyways, it's multiple kilo ohms. Okay. So this guy is probably in the 1K range. So you're looking at like a 10K, 100 ohm, and then like a 1K or a 5K, maybe a 2K, but I would imagine less than a 10K. No, maybe you put a 10K here, it's paralleling to this. Maybe you put like a 10K, 4.7, 4.7, right, 10. And then the lowest that this would ever go would be like 4.7 divided by 2, because those guys basically become parallel. And then the max would be 4.7 parallel to, say, 15K. So which would be less than 4.7 on average. So 4.7 parallel 15, you're probably looking at like 4,200 ohms, something like that. So yeah. Okay, let's jump over here. Let's redo the layout. Okay. All right, so let's put this guy, well, on properties. Let's put this in the middle. Okay. Properties. 25. Can't just type it in. That's fine. Let's see, R7 is up on the top side, which R4. We're going to set down R4. This is the top side. R8. It's got to be this guy. So we got R4 and R8. So this is the collector, right? And R1 and R3. So R1 and R3. And then C2 for the AC coupling, C2. And R2 on that one. Okay. I'm going to put that guy rotates. Okay. 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 Yeah. The input capacitor. One more click. Okay. I'm locking that on the top because why not, right? You got the space is there, so we'll set it on the edge. Maybe that's the exact wrong thing to do, but you know. Oh well. Let's look at this on the 1 millimeter grid. So that's 1, 2, basically 3 off the side. And this it would put it 1, 2, a little bit more than 3, like there. That should be symmetrically off the side. No. Okay. That'd be close enough. Yeah. Okay. Should put these closer to the edge, huh? So I can have more room in the middle for test points. Okay, I could drag that down. put the test point on the end out there. Like that. Like that. TP4 is the ground test point. That should go back there. Okay, kind of like that. TP3 is power. I think I want to put that. Yeah, we'll keep it down here. So clean up the names. Okay. TP8. You know what? I'm going to put TP8 down off the cap. And then schematically, and then physically, we'll place it down there too. Yep. Okay. TP4. It's almost as if I want TP4 back here. But maybe I'll just leave that there for now. It'll be fine. Okay. We'll do a top trace to get over the output and send it over there, and then we'll be on the bottom pretty much everywhere else, I believe. Yeah. Okay. All right. Like I said, top trace. bottom. Sure. Hey. Okay. So if I slide that up, can I squeeze the test point in there? Oh. It'll work. It's kind of tight, but oh well. I think it'll work. Yeah. Oh, you know what would be better? What's going on there? There we go. Okay. Half millimeter, 0.5. It's an irrational aesthetic thing. Okay. Hmm. Does that have to go on the top? Pretty much. Pretty much. I could push it to the bottom right here, though. I don't have to drag it all the way. Or I could drag TP3, TP4, and then put TP1. Yeah, we're doing that. That's better. Okay. Here. No. Just, here, we'll do this. What? Oh, my bad. Wrong one. Oh, wrong one. Cancel. Yay. Cool. Okay. there. This guy goes here. Okay. So like that. Top. Like that. Now bottom. That's less cutting on the top. So probably go with that. We'll just leave it. It's fine. I think that's it, guys. X, B. Yeah. Okay. Refresh names. Execute. I mean, I could drag this cap and test point down further and get a little bit more room away from the okay. I think it'll be fine. I don't know if it's a big no-no to put the test point in the signal path. But then maybe including or excluding or removing the test point could have more of an effect on the signal than like if it's out here on the end. And since I don't know, we're going to go ahead and leave it like this. Maybe the real answer is, well, it depends on what your final assembly in production is supposed to look like. And if it's supposed to have a test point there, then it's probably okay. But if not, then probably don't. Like this right here, easy to remove and then easy to justify. Yeah, it's not going to affect anything on anything. It could only affect it in a positive way by removing unnecessary copper. But removing this guy, I don't know. I think it'll be fine. We can move this 0.5 millimeter. Okay, a full millimeter. That guy's close, but the cap could be closer to the, but I guess it's okay. It's fine. Is that wind outside? I think that's wind outside. Wonder if it's going to rain. It was supposed to be raining today. Okay. No feedback on this board? Yes or no, Nolan? Yes or no? Got plenty of room. put a resistor in a cap. Okay, put a resistor in a cap. I really want to do feedback. Save. Huh. Okay. Well, if that guy didn't, that guy didn't, that guy shouldn't. Ooh, and we get to put one more test point. There we go. And that will let us observe the feedback current signal. Yeah, I think that's good. It's a busy circuit for a beginner. Well, let me just add a pot. It'll be great. Pot and test points. It'll be fine. Okay, squeeze these guys in. Okay. Let's see, what do we got here? So this guy goes from there to there. So maybe let's put this guy back here. Okay. That's centered on it. Okay. 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 that. Keep it centered. I think we keep it centered. Then we can rip up this. We can grab this guy, move him this way. This guy, put it this way. Test point 2. Put test point 2 here. Okay. Test point 11. It's fine. 11's fine. One more click that way. Rip up. Okay. What happened? Oh, my refresh names thing ripped up my traces again. Oh, it was doing this last year. What is up with that script? It just gutted my board. That's why. This is why I stopped a year ago. I was discouraged by this. Just like ripped up and threw it away. Well, that's definitely thunder. Well, I'm gonna end the video here and keep working on it. Suffering in silence. Thanks for hanging out and watching. I'm gonna get that up and going. You can kind of see where the board is at. So I'm gonna pop that up, and then I'll do another video making the next mini PCB. So cool. Anyways, thanks guys. Thanks for hanging out. We'll see y'all next time.